All right, let's start division. This lesson is still 3.OA.3 division. This is also a numbers and base 10 skill. Okay, kind of go hand in hand. Operations and algebraic thinking just includes it in a word problem. Division. Well, what is division? Division is repeated subtraction. So if we repeat something, that means we do it over and over. So look at this example. Our dividend is 36, and that's what we're dividing up. We're taking 36 of something and giving it out. We're dividing it by 9. So look at this as 36 pieces of candy, and we're dividing it amongst 9 people. Well, we want to know how many pieces of candy would each person get. When you set up a division problem, a lot of students get confused. They don't know which number goes under the bracket and which one goes on the left side. The number that goes under it is always first in the division problem. Now in lower grades, normally the biggest number leads the division problem, but as you get older in higher grades, you'll see that the smaller number can be first as well, especially when dealing with fractions. 36 is the dividend, 9 is the divisor. So since I'm dividing by 9, that's the amount I'm giving out each time. So I'll subtract that amount over and over from 36 until I get a remainder or a difference that is less than my divisor. I was able to subtract 9 4 times before I got a difference that was lower or smaller than my divisor, and that difference was 0. I then circled every time that I subtracted my divisor, and that number became my quotient. So let's do a few. Okay? Let's do a few. If I give you something like 100 divided by 20, because we kind of get scared of big numbers, and we shouldn't. The process is still the same. When I set it up like a regular division problem, 100 is first, so that's my dividend. The 20 is second, so that's my divisor. Okay? Those arrows just help us keep things placed correctly. And it's important that you write neatly. Okay? I ask myself, especially if I'm using a repeated subtraction method, and that's the one we're talking about today, repeated subtraction. Okay? You can find the DMSB loop in another video. I'm going to subtract 20 over and over. But first I ask myself, where do I begin? Look at what you're subtracting. Look at each individual digit in your dividend and see where it's best to begin. If I'm dividing 20 into 1, could I go? Could I put 20 into 1? No, 1 is too small. Put a 0 up there. Now don't just look at this as a 1. Look at it as a 10. Can I take 20 from 10? No, 10 is still too small. So I put a 0 on top of that 0. Well, look at this as a 100. Can I take 20 from 100? Ding, ding, ding. Yes, I can. So start the subtraction under the 100. Okay? 100 minus 20 is 80. Do I have a number that's smaller than my divisor? No, Mr. Gray. So keep going. Keep subtracting until your difference is smaller than your divisor. And I'm done. I found a difference that was smaller than my divisor. Now, I look and circle everywhere that I subtracted 20. 1, 2, 3, 4, 5. So my answer is 5. So 100 divided by 20 is 5. Well, we can use multiplication to check that division problem. I can go backwards and do 5 times 20 to see if it equals 100. If I set it up vertically and use the standard algorithm, 0 times 5 is 0, 2 times 5 is 10. Okay? So it looks like we're correct. Let's try another one. Okay? Let's try another one. Let's do 144 divided by 12. Okay? Set it up like a regular division problem. Since the 144 is first in the problem, that's your dividend. And the 12 is the divisor. Since the 12 is the divisor, that's what we're going to subtract over and over and over. But I first have to identify, where do I begin subtracting? I ask myself, can 12 go into 1? And you say, no, Mr. Gray, 1's too small. So I put a 0 on top of that digit. Ask myself, can 1 go into 14? Can 12 go into 14? Yes, Mr. Gray, 14 is big enough. How many times can 12 go into 14? If I'm not sure, I can make a list of multiples for 12. I know 14 will fall between 12 and 24, but I want to take the factor that's less than where I am. So I put a 1 up there. Okay? Or I could just easily subtract 12. And I get 2. Okay? 12 can't go into 2, so I'm done there. Circle it one time, because my difference is smaller than my divisor, and that's where that 1 comes from. Now I bring down the 4 and continue subtracting until I get a difference that's smaller than my divisor, which is 12. I'm done. I got a difference that's smaller than my divisor. Keep in mind that when I circle these 12s, it's aligned with the 4 here. So put this 1, 2 here. So 144 divided by 12 is 12. Okay? One more. If I do 50 divided by 10, I know 50 is my dividend, 10 is my divisor. I will keep subtracting 10. Until I get a difference that's smaller than my divisor. And I did. 0 was smaller than that 10. Circle everywhere that I subtracted 10. 1, 2, 3, 4, 5. So 50 divided by 10 is 5. I can check it by multiplying. 0 times 5 is 0. 1 times 5 is 5. So 10 times 5 is 50. And that's how we multiply, or divide, excuse me. Always reference division with subtraction. It's just repeated subtraction.